Okay, good morning all of you. In today's session, we are going to start a new topic in physics, and the name of the topic is capacitor. So it's a completely new topic. So what is a capacitor actually? You see, what happens is that in the various sessions of electrostatics that we have had up until today, we have discussed a lot of aspects of electrostatics, and one of them is energy. Now, electrostatic energy, uh, can it be contained? Can you and can it be contained and can it be utilized? Can you contain electrostatic energy, and after containing it, can you utilize it? So the answer is yes. And the means of doing that is called a capacitor. So capacitor is a means to contain electrostatic energy and then put it to use at some later stage. So what we do essentially in a capacitor is that we take two metallic uh, well conductors which we use in normal circumstances. They are all metallic. Like, we all know what are conductors, but the ones which we prefer to use, they are metallic. So we have two equal and oppositely charged conductors placed very close to each other. So there's a conductor with a charge plus Q, there's another conductor with a charge minus Q, and the potential of this is V plus and the potential of this is V minus. So obviously, because this is positively charged, so it will have a higher potential, and this is negatively charged, so it will have a lower potential. And the potential difference between those placed close to each other, and the charges on them are plus Q and minus Q. The potentials are V plus and V minus, and the potential difference between them is V plus minus V minus. That we call it as V. So the charge on either conductor is proportional to the potential difference between them. So the charge on either conductor is Q. Q is proportional to V. So if you remove proportionality, the constant of proportionality is C. C is the capacitance of this assembly. Like, C is the capacitance of this pair of conductors, and C, the SI unit of C is obviously Q is equal to CV, so C will be Q by V. So the SI unit of C will be Coulomb by volt, right? Because charge is measured in Coulomb and V is measured in volt. So the SI unit of C will be Coulomb per volt, and Coulomb per volt is called Farad, right? Coulomb per volt is called Farad. So a capacitor, what does it do? So we'll discuss that as we progress with this chapter. But what essentially does a capacitor do? A capacitor is a storer of electrostatic energy. A capacitor is a device which stores electrostatic energy, and you can use that energy later on. And there are so many places where capacitor is required. Almost all electronic circuits require capacitor. Almost all, without fail. Electrical circuit, I can give you a very good example of capacitor is the ceiling fan. You will see that in a ceiling fan there is a small cylindrical thing, and that is actually a capacitor. So its job is to regulate the speed of the fan. You are aware of regulation. There is a manual regulation 1, 2, 3, 4, 5 we do for ceiling fan. So the capacitor is the one which is responsible. Electrically speaking, it is responsible for regulation. So at the moment, that's all we will do. That capacitor is a storer of electrostatic energy, and that energy can be put to use on a later date as per the requirement. And the charge on either of the two conductors is proportional to the potential difference between them, and the proportionality constant is C, and the SI unit of C is Coulomb per volt, which is Farad. So now I'll give you the usual homework. Okay, so these are the two homework questions based on today's session. Question number 1. A capacitor when charged to 1000 volt takes 2 microcoulomb of charge. Find the capacitance. That is the first question of today. Okay, a capacitor when charged to 1000 volts take 2 microcoulomb of charge. Find the capacitance. Question number 2. A potential difference of 250 volt exists across the plates of a 25 microfarad capacitor. Okay, a potential difference of 250 volt exists across the plates of a 25 microfarad capacitor. So find the charge on each plate. So this is question number 2. So total there are 2 questions and you can submit your homework anytime by 9 p.m. tomorrow, that is Saturday. Okay, so I'll end the session. Bye all.